All right, a little help on that apartment problem. Here is an example. I don't know if it fits your data or not, but the particular problem that I'm looking at, it is the rent is $530 for a full house, and every $50 increase, so it starts with $530 in rent, and if you increase the rent $50 to $580, we lose one renter, and so that's the $50 increase thing that I'm seeing right here. In my particular case, then the cost per unit to clean or maintain or whatever it is it's $45 per unit cost per unit every month. So those are the big inputs that go into mine. So I'm going to back that up a little bit just so you have a set of context when I get to those things in the problem. Yours will be slightly different than mine, and it'll have other numbers, and you just have to kind of roll with that. So here's how I set it up. I always make 2 points. I just put 2 points and I make them go downhill. I make them slanted downhill because I know a demand curve does that. And so then one of the points is for the full number of apartments, which for mine is 60 units. There was a price of $530, and so that's that first point that I put on there. And then the second point that I have on there is saying that after an increase of $50, they're saying what happens is that I lose one renter on average. That means I have 59 units when I go up to $580. So that's the second point that I put on there. That gives me enough for my line that I can do an equation for. That gives me the slope. It has a down 50 over 1 type of slope. So when I put that in as my slope as negative 50, then I can find a point, use one of the points that I'm given. And a point, again, is one of our how many units are sold at a given price. If I put those in as my P and X respectively, X is units, P is price for what you want to rent it for. If I sub those into that equation for P and X, and then I solve for the y-intercept B part of the equation, so I have a nice linear demand, then I can kind of unfold these numbers here. I get negative 3,000 on the right, and then I can add 3,000, so 3530 is my B. So what I end up with is this nice looking little demand curve that is what I'm going to substitute. That's not the whole thing. That means for a given price, this is the number of units that will be rented, or vice versa. If I want to rent so many units, here's the price. It's just the relationship between those. It's only part of the puzzle, because what I do with that is I take it, and I should back this up just a little bit here. What I want to consider is here's the whole page, and I'm just going to kind of highlight through things. The thing that I just got was this P that goes into my profit is revenue minus cost. And revenue is composed of X units times P price, and that little P price stands for this P equation that I just came up with. It's highlighted there in green. So what I do is I substitute in the stuff I know. And by the way, remember my fixed cost is $25 per X unit. So this is using the demand curve I just developed, goes in for P, times X is revenue, and then subtract 25X my cost. Altogether, there's my profit function. You can graph that. Now I have a graph on the next page if you want to take a peek at it so you can find it there so we can go get these things. But the big deal is when I get the equation in this form, I want to simplify it for the big purpose, which is if it's cleaned up a little bit, added like terms and distributed the X. For instance, I distributed the X and combined the 3530X and the 20 minus 25X. And I'm left with 3505X. That's just algebra of combining things. There's no derivative that took place there. That simplified version, I do want to take the derivative of and set equal to 0 so I can locate a maximum or a minimum. And this graph just has a maximum. It's just an upside down parabola. So if we set it equal to 0, we know we're going to be finding the peak. And so I've done that here. And if you start solving for X, which is also down below, you get 35.05. Now, these are the units rented, and WebAssign's been a little iffy on how it's accepting these, but you can't rent a partial unit, so we would round this to 35 units. That's my perspective. Sometimes it wants you to round up and down, and it hasn't been consistent on your homework, and that's something you want to mention to me. If you think you got it right, but it just keeps marking you wrong, just let me know. So I use that, by the way. I put that $35 back in my price equation because the question is, what's the price that maximizes profit? Not the number of units. So the other big error I've noticed is that folks are putting 35 in for an answer, but that's units. It's not the price that we're supposed to be charging. Put the 35 units into the price function and you get out 1780 in price. So by the way, I was keeping this all graphed and I kept my eye on this picture when I'm graphing it and I see, oh yeah, there's 3505, there's my maximum profit of 61,425 in a month. That's pretty nice. But 35, remember, is units. If you want price, we had to go back and put the units into the price function. Hope that helps you in your situation.